We need to be able to classify chemical reactions. And there's two main ways of classifying. You can classify them by what happens. So the chemical reaction, does a solid form? Well, that's a precipitation reaction. Do we have an acid and a base forming water and salt? It's an acid-base reaction. Do you have gas being formed? That's a gas evolution reaction. Do you have electrons being transferred? That's a redox reaction. And a subset of oxidation-reduction reactions are combustion reactions. You have electrons being transferred, but you also have the reaction with oxygen. One equation can fit in more than one category. We can also classify them, the reactions, by what the atoms are doing. So a synthesis or combination reaction, we have two substances combining into one. So you can identify a combination reaction because you have two or more reactants, only one product. A decomposition reaction is kind of the opposite. You have one reactant and it's decomposing. It's coming apart into two or more products. We can have a displacement reaction. I'll talk about that in a minute. Or a double displacement. Double displacement is what we saw with the acid-base reactions and with the precipitation reactions. So we have A and B coming in together to the party. We have C and D coming together, but they swap partners. They leave with different partners. A came in with B, but he's leaving with D. Okay? In a displacement reaction, this is where we have, this is usually a metal. So we have a metal in an ionic compound. So the metal is a guy going stag to the party. He's going by himself. He couldn't find a date. So he shows up at the party, and here are B and C. They came to the party together. And now C decides that A is more attractive, and so she leaves with A, and B goes home by himself. It happens sometimes, doesn't it? It does. So that's a displacement reaction. It's also called a single replacement. One person got replaced. One person got displaced. And then here are more slides showing this. So here's an example of a combination reaction. Here we've got sodium and chlorine, combining, and they form one substance combination. When we look at the formula, we've got Na plus Cl2 forming NaCl. Decomposition, you can do this with a 9-volt battery and some tap water. We take one reactant, water, and we do something to it. Here we're passing electric current through it, and we decompose it into two substances. Single displacement, here's an example of that. If you take a piece of zinc metal and stick it in a solution of copper chloride, the chloride thinks that zinc is cooler, and so the zinc leaves with the chlorine, zinc gets the girl, and copper is left by himself. Single displacement. Two elements or groups of elements exchanging places, that's the double replacement. And we see this with precipitation reactions, acid-base reactions, and gas evolution reactions. So here's the flow chart for classifying things by what the atoms do. Synthesis, decomposition, single displacement, or double displacement. So this is what you should be able to do for the exam. Classify each reaction as one of these four. So let's look at this one. Well, we have two reactants and two products. That rules out combination, synthesis, and decomposition. So it's got to be single displacement or double. It's a single, right? Because here aluminum came by himself and there hydrogen is leaving alone. So this is single displacement. I'll call that SD. How about the next one? Copper sulfate, potassium hydroxide, forming copper hydroxide, potassium sulfate. Double displacement. Here we've got copper coming in with sulfate, leaving with hydroxide, potassium coming with hydroxide, leaving with sulfate. That's double displacement. How about K plus Br2 to give KBr? Combination or synthesis? Synthesis, because that's what the word is up here. And then what about letter D? Decomposition. We have one substance decomposing into two elements.